Hello everyone. So now we discuss about an example problem on Lamis theorem. So how to apply the Lamis theorem for this given problem for finding the required tension in a string AC and tension in a string BC. Okay, here the problem is given. The two strings are connected AC and BC. One is at the roof and one is to the wall. So at the contact point of these two strings, a load of 50 newtons is connected. So in this condition, we need to find out what is the tension in AC, what is the tension in BC. So before that, we have to know how to find the angle of inclination in between the two strings. So for that, separately I want to draw the free body diagram for the three strings. Okay, sorry, here it is not straight. Okay, I want to make it straight first. So vertically downward, 50 newtons load is acting. Okay, so in this condition, assume this point as C, and with respect to that, the tension in BC AC string is AC and tension in a BC string is TBC. Okay, here in the problem it is given 60, so here we need to find out angle between BC and AC string. So for that, I want to separately represent here again for finding the angle of inclination. Assume this is BC, this is AC. So from B I want to draw a horizontal line. Okay now, so here automatically if it is 60 means this will be also 60 because it is also horizontal line like roof you can assume. And here when you draw a vertical line from B, so the angle of inclination is given 45. So in the figure it is given 45. When you draw a horizontal line, then the angle becomes 90 degrees. So 90 minus 45 will give you again here 45 degrees. So from the triangle rule, sum of all angles should be equal to 180. Okay now, so this angle will be equal to 180 minus sum of these two angles. So for this required angle is equal to 180 minus 60 minus 45. So here automatically by the simplification we will be getting 75 degrees. So automatically here this angle of inclination is 75 degrees. Okay, so up to now the angle between BC and AC string is over. Next we need to find out angle between BC string and the string to which a load is connected. Okay, for that again separately we represent and we go for simplifying. Okay, so now I want to draw BC string and the load string. Okay now, so this angle is already given as 45 degrees. Okay, so when you draw the horizontal line, this one will be 90 degrees, so this one will be 45. So again 180 minus, so for getting this angle 180 minus 45 minus 90 will give you again 45 degrees. So that means here this angle is 45 degrees again. Okay now, so again this one automatically will be 90 degrees. So 90 plus 45 will give you 135. So that means this angle of inclination is 135 degrees. Similarly, we need to find out angle of inclination between AC and the 50 newtons load string. So for that also we go for separate representation for analyzing. Okay, so now again try to draw the AC string and the 50 newtons string. Okay, so this AC string is already making an angle of 60 degrees with a roof. So similarly, if you draw the horizontal line here, so from the parallel lines theorem, here also will be getting 60 degrees. So this is automatically 90. So sum of these two will give you 150 degrees. So automatically this angle of inclination is 150 degrees. Okay now? So we have determined all the angle of inclination in between the two separate strings. So now we can apply the Lamis theorem. So now next we go for application of Lamis theorem. So next we are going to apply Lamis theorem. So how to apply the Lamis theorem here? Okay, now so that means here Lamis theorem states that uh, what is that the force is directly proportional to the sine of angle between two other forces. Okay, na? So that we can write it as, first we start with TAC. So TAC by sine of the opposite angle. TAC, the opposite angle is 135. So 135 degrees is equal to, and again try to write TBC. TBC is equal to again sine of opposite angle is 150 degrees. 150 degrees is equal to T, not T, directly we can consider it as 15 newtons. Okay, now so here you need to write 15 newtons. Okay, so 15 by sine of angle between opposite two strings. So what are the opposite two strings means? AC and BC. The angle we got it as 75 degrees. Okay, now so from this relation which is obtained by the Lamis theorem, we will go for the calculation of tension in AC, tension in BC. So for calculating tension in AC, try to take these two extreme ratios. Okay, so TAC by sine of 135 degrees is equal to 15 by sine of 75 degrees. So now in this equation write down TAC is equal to 15 into sine 135 degrees divided by sine of 75 degrees. So use the calculation, try to simplify sine of angles. So sine of 135 will give you 0.707. Okay, and next sine of 75 will give you 0.9659. So simplify by using the calculation again, then write the TAC is equal to 10.98 newtons. So using the calculation you will be getting this value. Try to check the value. So next we go for finding the tension in a string BC. So take these two ratios here. So TBC by sine of 150 degrees, okay, is equal to 15 by again sine of 75 degrees. Okay, now write it as tension in BC string is equal to 15 into sine of 150 by sine of 75. So again by using the calculation simplify the values of sine of angle. So sine of 150 will give you 0.5. Okay, now and next sine of 75 again it will give you 0.9659. So again by simplifying by using calculation you will be getting the value as 7.76 newtons. Okay, that is the tension inside BC. Okay, now this is the way of calculation for finding the tensions in the strings when the two strings are connected with a load 15 newtons like this. Okay, by applying the Lamis theorem. Okay, this is an example we can consider for Lamis theorem for finding the required forces. So I hope you understand. It's a simple example problem on Lamis theorem. And if you still have any doubts, please feel free to give a comment to my video. Then I can clarify your doubts. And once again, thanks for watching my video. Thank you all, and please subscribe to my channel.